Okay. All right. That's good. So, and Sanvi, how about you? Sanvi, can you talk? You're not well, but you can talk. Just the video is off, right? Or what was the message from your mom? Let me just see. She'll attend the class, but just cover alert with the video off. Okay, Sanvi, you'll be participating in class. I cannot hear you though. If you're saying something. All right, cool. Let's get started. Just paste this question first. So first question, right? Yeah. So Veer, can you explain what did you get on this one? Were you able to do this one?
Yes, I was.
Go ahead.
The first question I got C.
Okay.
Because 2013 implies that it must be 3 modular B, because it ends in the digit 3, right, in base 10. So because B is a factor of 2010, we can then infer through a little bit of calculation that C is 13, that the answer is C13.
No, can you take us through the calculation? So basically, understand that it's the remainder is 3. Okay. After that, can you explain?
Okay. Then it must be 3 mod B, and wherein B is a factor of 2010.
Well, why should be a factor of 2010?
Because it's in base 10, right?
Okay. Sorry. So any base, right? So 2013, the remainder is 3. Yeah, understand. So in any base, we must have a remainder of 3. Okay.
Yes,
Can you go on after that? Yeah.
So now the factors of 2010 are 2, 3, 5, and 67. And then
so basically we start with prime factorization of 2010. Okay. Yeah.
Yes, exactly. And then we can conclude that there are 16 factors because 1 plus 1, 1 plus 1, 1 plus 1, 1 plus 1 multiply and you get 16.
Okay.
Right. And because B cannot be equal to 1, 2, or 3, the answer must be 16 minus 3 is equal to 13.
Okay, for how many positive integers? Yes. Okay, and B cannot be 1, 2, or 3 because
1, 2, or 3.
It cannot be because why can't B be 1, 2, or 3?
Because that would throw off the entire calculation, right?
Like in what way?
So I'm not quite sure. But I mean, I just kind of took an educated guess about 1, 2, and 3.
No, you should be able to explain your answer, right? So if you're saying it cannot be 1, 2, 3, there must be a reason for it, right? Navya, were you able to do this one?
Yes, I think like based on what I heard, I did a similar method.
Yeah. Can you help complete the last part? So Veer says the last what digit cannot be 1, 2, or 3.
Yeah, because if you're taking base 1, 2, and 3, then like 3 can't be the last digit. Because otherwise then like it goes to the other digits.
Exactly. Does it make sense, Veer?
Yes, it does.
In fact, that was one of the easier steps, Veer. Having come this far, you should have been able to conclude quickly that B cannot be 1, 2, or 3. Does it make sense?
Yes.
Okay, Aditya, you're okay with the explanation or should I repeat it? Suhani, turn on the video, please.
Oh, yeah, sorry, my internet's a little not working today.
So very able to do this first question, Suhani.
Yeah, I got 16 as well.
So, but 16 is not the answer.
Oh.
Yeah. Okay, yeah, which is why the 16, there's a choice which is 16. So till here, everyone is fine. So it should be 2010 plus 3, right? So we are looking at factors of 2010, factors of 2010. And then by prime factorization, you get it as 2 into 3 into 5 into 67. And therefore, it has 16 factors. But then the last concluding step is important, right? The base, if there's a digit which is 3 in it, right? Ends in digit 3. That means the base cannot be 3 or 2 or 1, right?
Oh,
because,
okay.
Does it make sense? It has to be a higher base than that.
Yeah.
Okay, let me just ask another question on this one. Okay. Can you guys write this 2013? Sorry. Okay. Can you help write 2013 in base 15? So we studied how to do it in base, right? Can you write 2013 in base 15? So I'll be asking variants of the questions here, guys. Okay. So only then I can be confident that you've actually understood. Okay. So can you write 2013 in base 15? So base 15, you can use the digits all the way from what to what, Veer? If I have to write base 15, I can use the digits from how many digits
So
do
you
I
can
have
use
in
so you can use the digits from 0 to E.
0 to E? Excellent. Yes. Which will be how many digits?
That's 15 digits.
15 digits. Okay. Now, can you all write this number 2013 in base 15, please? Whoever does it first, you can just call out.
So I have a question.
Yes.
In AMC10, are calculators allowed?
No, not allowed. Okay. Anyone?
I got 8D3.
8D3. Excellent. 8E3, you mean, right? E for elephant?
Yeah.
8E3. Correct. Anyone else get the same answer? Suhani, are you able to turn on the video by now? Suhani, I'm talking to you. Suhani, are you around? Okay. Aditya, we're able to get this 83.
So no.
Okay. Do you want an explanation, guys, or you're okay?
So I'll take a look at the recording of the other one where you explain it, and I'll just see.
Okay, that's fine. We can just do a quick one right now, right? So basically, yeah, do watch that recording. So we'll keep putting digits, right? The units digit will have a weight of 15 power 0, or essentially 1, right? The tens digit, so quote unquote tens digit that we call, will be a value of 15. The next digit will have a value of 15 square. The next digit will have 15 cube, and so on, correct? What is 15 square? 225. 15 cubed is 225 times 15, which is some 3000 plus, right? And we are talking about a smaller number than that. So we don't have to go to this digit at all. You're going to achieve our result even before that, all right? So how many 225s can we accommodate? So which is why a bit of mental math, not too much, right? 225 times 2 is 450, right? How many of 450s can we pack? 50 times 2 is 900. 900 times 2 is 1800. So and then if I had one more 225, it just exceeds, right? So it becomes 2025, right? So it's somewhere between 8 and 9 225s that I need, which means I'm okay with 8, and then the balance I'll fit using the remaining digits. Is this clear so far, Aditya?
Yes, sir.
Okay. And then if I fit 8 of those, the balance is how much? From 2013, I subtract 1800. So it is 213. So how many 15s can fit in this? 15 into 15 is 225. 15 into 14 would be just before that, right? Which is 210. So I need a digit which is called 14 here. And then a digit called 3. A digit called 3, we have it in our kitty, no problem. Digit called 8 also we have. 14 karke, there's no digit. It's an artificial digit we have to replace. So we know the digits, right? So till 9, we have all the digits. After 9, people invented these letters to represent. It's just known convention, right? Why A, B, C, D, why not P, Q, R, S, T, right? So one could, or why not some symbol like this, some symbol like this and all that, right? So, but just for convenience, people said, okay, after 9, we'll go A, B, C, D, and so on, right? Okay, so this is how much? So this is 10, 11, 12, 13, and as Veer was telling, 14 is the highest possible, right? So we replace this with E. Does it make sense? Wonderful. Okay. Quick question, all of you. Using the letters of the alphabet, all the letters of the alphabet. By the way, I see still people making mistakes like alphabets. Alphabet is singular. The English alphabet has 26 letters. Okay. So some people say that 26 letters, 26 alphabets, 26 letters in the English alphabet. Anyway, so what is the maximum base I can achieve using all the letters of the alphabet? Okay. If I can go A, B, C, D, E, so on till Z, what will that base be?
Base 35.
Exactly. So A is 10. We just have to add 25 to it. I was hoping someone else would answer it. But yes, A is 10, and then we keep adding 25 to reach Z. So base 35 indeed. Yeah, does it make sense, everyone? Sanvi, how do I know that you're getting something or not? You're not able to unmute and say yes. Is that much something you can do, or is it throat bad, or what is bad? What is wrong? Sanvi, can you unmute to talk once with me?
Oh, my throat is bad.
Throat is bad. Okay, fine. I won't ask you questions, but I need you to acknowledge saying you understood or not by, if I ask in between, is it okay? Then you must at least say okay, because I'm not actively watching chats. Is that too much to unmute and say yes?
I'll show the reaction.
Okay. Okay. Well, so, okay. All right. You sound really bad. Okay, fine. I won't bother you, but I don't know. It's up to you to ask questions, right? So maybe raise your hand if something is not clear. Otherwise, I'm going to assume all good. Okay. So that was first one. Okay. Question 2. Yeah. So, Hani, were you able to do this one?
Yeah, I made an attempt. So I got to the point where you could like find the factors of like each of the combinations. So for A, B, I got like this LCM was 12x.
Mhm.
And then the possibility for B and C was 20x. And then for C and A, it was 15x. And then I found the lowest like common multiple of all three of them, but I wasn't really sure like where to go from there.
Okay. Good start. Okay. Suppose it's just 3 and 4. Let's focus on only those cases where A and B will go, but C will not go. Can you tell me how many numbers will be there like that? Suhani. Just continuing on the 12x a little bit.
Oh, yeah, sorry, can you repeat that?
So, yeah, I understood till 12x, 20y, and 15z. Okay. So how many days will be there when A and B, as in the 3s and the 4s, will meet or visit, whatever, but not Claire?
So would it be 30?
30. 30 would be for A and B visiting, right? But not Claire. So how many
Yeah.
of these 30s will have Claire also?
36?
Why 36? Sorry. This 30 we agree, because why 30? Because 12 times 30 is 360, right? That's why you said
Yeah.
30, correct? Now, so which means they'll meet on the 12th day, 24th day, 36th day, and so on, all the way till the 360th day, right? On some of these days, Claire will also visit, which I don't want. I want only A and B to visit, but not C, correct? For example, 360 itself is one of them where Claire will be visiting, because 360 is a multiple of 5. Agreed. So how many of these 12, 24, 36, and so on will include Claire also? Which will be the first day when Claire also shows up? Show me, tell me.
It if the LCM is 60, it would be
Exactly.
six. Yeah.
Yes. So 6 exactly. LCM is 60, right? 60 is the first time that Claire will also show up. Therefore, I don't want to count. 120 is the next date when Claire will also show up. I don't want to count it. Like that, like you rightly said, I'll subtract 6 of them. And therefore, there'll be only 24 days when A and B visit.
Oh,
Yeah.
okay.
Does it make sense? Okay,
Yeah.
Aditya, are we able to complete this fully? Similar logic?
Yes, so
And what did you end up getting finally at the end of the full problem?
I got 48.
48. Okay, all right. Peer, what did you get?
I got the same one. No, wait.
This is question 2.
I got 54. Sorry. I was looking at
54.
a different one.
Okay, Navia, what about you?
So initially I got 66, but now that you just explained it, I resolved to get 54.
54.
Yeah, I'm
Oh,
also
yeah.
getting 54 now that I'm
54, right? So yeah, similar logic. So 20y, there'll be 18 of them, 20 times, and then there are 6 we need to subtract. 15 into 24 would be 360, right? Of which I need to subtract 6 for the same reason. So there'll be 12. I don't know why I'm putting squares on all of them. Okay, fine. So this sum adds up to, right? Whatever, 54. Yeah. Okay. Let me just think different variant of this question. One sec. Okay, all right. Variant of this question. How many days of the 365 period will have exactly one visitor? So instead of exactly 2 visitors, exactly one, just replace the word 2 friends with 1. Okay, obviously the choices won't be there here because I made up this question, right? So can you all work it out? Someone dropped out. Who was that? Aditya. Okay, all right. Looks like. Suhani, what about forgot your brother's name now. He's not attending today.
Oh yeah, he won't be able to attend. I think my dad messaged you.
No, I didn't get a message. That's fine. Carry on. Okay, Navia's hand is up. Okay, Navia, call out your answer anyway.
I got 216.
216. Okay. How long more should I give Veer, Sanvi, Suhani? Okay. All right. Let's discuss anyway. Navya, can you, Aditya, you joined back? I don't know when you joined back. Did
Yes,
you understand how we got 54?
So yeah, I disconnected after that.
Okay. All right. Sounds good. I just made a small change to the question, another variant. I replaced, instead of 2 friends, I said 1 friend. Okay. And so
Okay.
far, Navya's called out her answer is 216, and we're going to discuss. Navya, go ahead. Please take it away. Explain why 216.
So basically what I did was the number of times A visits, like A is Alice, B is Beatrix, and C is Claire. So
Yeah.
basically I did 360 by 3 for Alice, plus 360 by 4 for B, and 360 by 5 for C. But then I realized that I'm double counting a lot, because A and B, like the times A and B visits together, then B and C visits together, then A and C visit.
Okay.
So
So this is A is 120. B is how many?
90,
90. And this is
72.
how much? 72. Okay. All right. And now how are we? So this is all. Yeah. This is counts for A, B, and C. And now after that.
And then you double counting a lot, because you also like double counting the days A and B visit together, B and C visit together, and A and C. So then I subtract that. So after that I subtract minus 30, minus 18, and minus 24.
So the 30 here, you mean? The 30 here?
Yeah.
Okay. And then the
Um,
minus 18 like this. Sorry, which 30 are we subtracting? I'm not clear what all you're subtracting here. So from the 120, you're subtracting 30 because.
it doesn't matter where you subtract from. Basically, I added all of these. Then
Okay.
I subtracted like 30, 18, and 24 from that sum.
30, 18, and 24 from the sum. So these are the cases when 2
They-
or more attend, correct?
Yeah. And then after that, I'm double counting the part where 3 of them meet together. So then I add 6.
But then how many times are you double counting that? So that part,
360
So-
divided by 60, because 60 is the LCM, right? So
60 is the LCM, but this 30 also includes the 6, this 18 also includes the 6, this 24 also includes the 6, right?
that's why I added 6 to that, the entire thing.
Let me think. So you're saying 120 plus 90 plus 72, okay, minus 30 plus 18 plus 24 plus plus what is this? Plus 6. Is this? Is this what you're doing, Nabia?
Yeah.
I'm still not clear on the plus 6 part. Please, can you explain again once more? So so this is all the total where you're independently looking at A, independently looking at B, independently looking at C. Okay, so this is, in other words, this is a number of A's, this is number of elements in B, number of elements in C. Now you're subtracting A intersection B and B intersection C and C intersection A. Okay, and this is A intersection B intersection C, correct?
Essentially.
Yeah. And this will give what?
216.
This will give 216. One sec. Let me just think about this for a second. Number of A's, just exactly 1 visitor, right? Subtracting cases where okay. Okay, I was thinking in a different way. Let's see whether both give the same answer. Yeah, I don't know. I'm not able to accurately say what you've done is correct or not. It seems like it's right. But what I was thinking was, yeah, the starting step is the same. 120 plus 90 plus 72. So I'll just put myself in blue. Okay, so 120 plus 90 plus 72. Now this is what? A and B together. A and B together, we said will attend 24 times. B and C together was 12 times. And A and C together was 18 times, correct? Now, in this 120 for A, this is B, and this is C. correct? In this 120 for A, I want to subtract those cases where A, B both attended and cases where A and C both attended, because I want only A to attend. So I'm subtracting 24 and 18. Okay. Are you with me, Navya?
Yes.
Okay. So I'm subtracting 24 plus 18. Likewise, sorry, my handwriting is noisy here. 24 plus 18. Now, likewise, when only B, so if I have to do the same for B, right? So the total for B was whatever that 90. So from this 90, I want to subtract those cases where B attended with some other partner, which includes these days and these days. So I want to subtract those days, right? So BC and AC, which is 12 plus 18. Okay. And then likewise 24 plus 12. But I'm double counting all of these days. Okay, one sec. Maybe you're right. Okay, divide by 2. And that's it, right? So essentially, what you have and I have is similar to here. I don't understand the last plus 6. Why are you adding this plus 6?
Because when you're subtracting like minus AB minus BC and minus AC, you're also like you're subtracting.
Oh, no, you're subtracting 30 plus 18 plus 24, which is different than mine, which is 24 plus 12 plus 18. Okay, let's see whether both give the same answer. So your, okay, just one sec. So 24 plus 12 plus 18, right? 24, 12 and 18. So which is how much? 24 plus 12 plus 18, which is the 54. So I have minus 54. What you have is minus 72 plus 6, which is minus 66. I think you have to subtract, you have to add 2 6s, not 1 6. Okay. Now, yeah, let me just find a flaw, anyone for that matter, right? Let me just write it out again. I'm not sure whether she's wrong or I am wrong. I just made up this question on the fly. So basically, my argument is, right? So only A, we agree there are 120. Sorry, not only A. I mean, as far as A is concerned, there are 120. As far as B is concerned, there are 90. As far as C is concerned, there are 72, where you don't worry someone else attends or not attends. Okay, so till here we are all fine. Now, so from this, I want to subtract those cases where 2 people attend, right? 2 people attend. Or rather, from the 120 days that A attended, I want to subtract those cases where A attended with a partner. Okay, so A attended with a partner here and here. Let me just erase this. A attended with a partner with AB and with AC. So there are 24 plus 12 days, so 24 plus 18 days where A attended along with B or along with C. So it's 120 minus 24 plus 18, where A attended alone. Is this right? Okay. Similarly, when B attended alone, I should subtract which days? Those days where B attended with a partner, which includes BC as well as AB. So the 24 plus 12, those days. Okay. Likewise, for C, which is 12 plus 18. And each of these days is getting counted twice. And therefore, it's just divide by 2, right? Okay, all right. Let me think about this, Navya. I'm still not, as I'm explaining this, I'm not very confident. Let's not waste class time, but nice way of thinking. I like your approach also. So either one of us is wrong or both are wrong. That's also possible, but I'll come back. Okay, cool, nice. Okay, question 3. Question 3. Okay. Suhani, you're able to do this?
Again, I wasn't able to fully solve it, but I got
Okay.
to the point where I
Okay,
got
so
to.
yeah,
Okay.
go ahead and explain till where you got, please.
So basically I thought like because like the K number of pirates would take the treasure, it would be like 11 over 12 and
Mhm.
then times 10 over 12 and then all the way till times till 1 over 12.
Yeah.
And then that times X, which is like the total. And then so the final bit I got to X times 11 factorial over 12 to the power of 11. But I wasn't sure like how to simplify that. And like I know we're not supposed to use a calculator, but like I
Correct.
like did to get the question.
Yes.
And
Okay.
so I just like divided X to see which one was a whole number because it says positive whole number. But I wasn't sure how to simplify it without a calculator. So yeah.
Yeah, you're right on the money. Just the last bit alone you didn't complete. So yes. So let's say just so that for people who might not have tried it. So this is, let's say, pirate number, and this is balance, right? So balance number of I'll just tell in terms of 1. So this is pirate 1. So in fact, I'll just say he takes how much, and then balance that's left in the kitty, right? So this guy ends up taking 1/12. Okay, so the balance that's left is 11/12. Correct? So pirate 2 comes, he ends up taking how much? 2/12 of this 11/12, right? So 2/12 of this 11/12. Therefore, what remains after he has consumed is 10/12 of this 11/12. Okay. And then next comes pirate 3. I mean, I'm sure you guys are all seeing the pattern. Then he takes 3/12 of the balance, which is this guy. I'm just writing it so that we're all comfortable. And therefore, the balance that's left would be 9/12 of the same 10/12 and 11/12. Okay, so now this is good enough to see the pattern. So when you have 3, the balance is 3 terms, 9, 10, 11, right? So likewise, if you go to 11, it'll have 11 terms, right? All the way till 11. So it has to start with 1. So which is why she said it's 1, 2, 3, all the way till 11 upon, there are 11 terms upon 12 power 11. And then when 12 comes, he will take 12/12 of this balance, which is essentially the whole thing. And therefore 0/12 of this will be left, which will be 0 left. Okay, so that's just to be explicit, I've written it out. Now, obviously you can see that this guy is the main key guy, right? I mean, this term is the main key term, which we want to make it an integer, right? So yeah, actually this is the fraction that I've written. All of this is fraction. The fraction that's taken and the fraction that's balanced. So this number must be an integer. So let's write it out. What is the number? 11. And 12 is not a big number, right? So we can or 11 is not a big number. We can literally write it out, Suhani. This is where just a simple bit of calculation will get us right over the line. So 4, 3, 2, 1, right? Okay, fine. I'll write 1 just for simplicity, right? And then there are 12 power. I'll just put a few 12s, and then I'm not going to write all the 12s. So there are 12 power. How many 12s are there in this?
11, right?
12, yeah, 11 12s. So I just wrote 3 12s for helping with calculations, and there's 12 power 8 more 12s left, right? I'll just say into. Okay, now we can start canceling very easily, right? So 2 and 6 cancel off. I'll do the cancellations in blue. So Suhani, this is where you're probably stuck. So 2 and 6 cancels off with 112. You with me so far? 4 and 3 cancels off with this 12. Okay. Any other big term? 9 and 8. 9 and 8 is 72. So let's erase 9 and 8 and with another 12, leaving a 6 here. Okay. Now I'll include a couple more 12s. So this 12 power 8, I can replace it with. So I have 5 12s right now. 1, 2, 3, 4, 5. And then I have how many? 6 more, right? 6 more or some, yeah. Total of 11 12s. Yeah. So 3 done, and then right now 6 times 10 is 60, and 60 goes with 12 5 times. Okay, now let's review the numerator. I think we have finished cancelling everything that's possible. So 11 into 5 in this 5 that is. And then there is this 7 and this 5. Right? And that's it. And divided by some number of 12s. How many number? 12 over 7, whatever. Right? So this into n or x, whatever you want to call it. Initial count, whatever, a or whatever. The initial count is, let's say, a number of. So this must be an integer, right? This must be an integer, which means a must be, he's asking what? He's asking how many coins does the 12th pirate receive, right? So a must be at least 12 power 7. And the bare minimum this guy will receive would be, the last guy will receive this much, right? A can be a slightly more also, as long as it helps with the cancellation. So this is 25 times whatever, 7 times 11, right? So this is 175 times 11. So that should be an answer close to 2000, right?
So it was 1925.
Yeah,
1925, 1750. Okay. All right. Does it make sense how, Suhani, you can cancel this easily?
Oh yeah, I think I just forgot.
Okay. All right.
How is that an integer? Because you have to do 1925 divided by 12 raised to 7.
Yeah. No. Times a, right? A is the total count.
Yeah, so shouldn't A be 12 raised to 7 so that the
But-
no cancel?
Yeah, a is 12 raised to 7. And the remaining is what this guy gets, right? So what this guy would get will be this number, right?
There you go.
Make sense? Yeah. Okay. Now, one other variant to this question. Okay, so this is the smallest, correct? This is the smallest. It says the smallest number of coins, right? Which will be the next smallest after this? Okay, don't call out if you have it. I want to give one is not answered. Okay, so think about it. If you have an answer, just chat it.
Repeat.
Okay, so this is the smallest. The smallest we all agree is 1925. What is the next smallest? Is the question clear, Navya?
Yeah, I just like.
Anyone? Veer? Any idea?
No, sir. Trying to figure it out.
Yeah. Anyone? Navya? It's actually not difficult, guys. Suhani. Why
I'm
did
not too sure, but I'm getting 3850.
exactly just the double of that? Instead of A, which is 12 power 7, it can be twice that. Everyone ends up getting twice whatever we got. so far?
Yeah.
Yeah, so don't doubt if your answer is seeming simple.
Yeah, I
Some of
felt
the
like a bit too
elegant
easy.
answers are the simplest. Yeah, so I'm sure you got it long ago, but you are thinking it cannot be so simple. Was it?
Yeah.
Yeah, but does it make sense, guys? Navya, does it make sense? It's just twice, right? So the bare minimum that A has to be is 12 power 7, right? So that the denominator cancels out, which is the next number where the cancellation will not be affected. Multiply by another 2. That's the smallest number you can multiply by, right? All good so far, everyone? Sammy, you're okay? Just give a thumbs up if you understood it. Okay, good. So that was the pirate question. Okay, the next one. We were able to do this, Joe and Blair. What is the 53rd number said?
Yes. Yes.
Yeah, tell me. What did you
I
get?
got E as the answer, 8.
Okay, please explain.
Okay. So we know that this can go on until 9, right?
Mhm.
And the sum of those numbers is 45. But we also know that at the 10th turn, the 8th number said is the 53rd number overall.
Yeah.
And 53 minus 45 is equal to 8.
Exactly. So we start with 1, 1, 2, 1, 2, 3, and so on. So the number of terms exhausted here is 1, 2, 3, and 4 here, and so on, right? So he's saying we can go all the way till 9, right? So that is a bit of an experimentation, right? So when you keep adding till 8, we get 8 into 9 by 2, which is 36. When you add till 9, it's n into n plus 1 by 2, right? Which is 45. If you go till 10, it becomes 10 into 11 by 2, which is 55. So somewhere in between this, right? Am I right? Yeah, correct. So then 45 has been uttered, and then we have to go till 53, which means 8 more. Yeah, same answer. Suhani, same. Fairly easy question, right? Navya, same.
Oh yeah.
Okay. Let me just. Okay. All right. Now the challenge is reverse. Can you make, Navya? Can you make up a small variant of this question? I want you guys to get into the habit of how else they can twist. Based on this similar framework, you can be creative, like you saw a couple of times when I came up with a question, right? So Navya, come up with a question, please. Or anyone, whoever comes up with, please call out. Don't just change the number alone and just say like when will
People now, like
sorry.
you can say A says 1,
Mhm.
second says 1, 3, 5, and so like 1 and 3, and then the rest like says 1, 3, 5.
Okay, all right. And then what's your question going to be?
What's the 49th number?
49th number. But it becomes a very similar pattern, no? Yeah. Okay, all right. I have one. I'll just continue with what you have only. Okay, all right. Okay, all right. So let's say this one guy, on the first day, he calls out the number 1, right? Second day, he calls out the number 1. There's only one guy. Third day, he calculates the sum of all these numbers on each day. He'll calculate the sum of all of these numbers, right? On which first day will his sum exceed 2000? Which will be the day number? So for example, you should say on the 38th day will be the first day when his sum will exceed 2000. Question is clear to everyone? So which is the first day when his sum exceeds 2000? So I'm still using Navya's number, so some contribution from her. 1, 1, 3, 1, 3, 5, and so on.
Wait, so on the first day he says 1, and the second day he says 3.
He says 1 and 3, or rather he counts, like he adds up the numbers 1 and 3. He adds up the first 3 odd numbers on the 3rd day. He adds up the first 4 odd numbers on the 4th day. Yeah. So any pattern observation, Veer?
I'm still trying.
Okay. Navia's hand is up. Okay, Navia, go ahead.
So I noticed like on like the second day, if you add it up, you get 4, which is 2 square. And the third day, if you add it up, you get 9, which is 3 square. So like
Exactly.
you get basically root 2000, which I got like around 44, and like 44 square is 1936. So in 45th day you exceed.
Excellent. Yes. Sum of odd numbers will be perfect squares. You did not know this earlier, Navia? The sum of odd numbers will be perfect squares?
This.
Sorry, you just noticed it now.
No, I knew this.
You knew this, right? So sum of odd numbers will be perfect squares. 1 plus 3 plus 5 would be 9. 1 plus 3 plus 5 plus 7 would be 4 square, which is 16, right? This sum would be 16 and so on, right? And even if we don't know this, we can just do sum of n terms in an arithmetic progression and figure this out. Suhani, you're able to understand, right? Why sum of odd numbers is,
Yeah.
right? For example, let's do the arithmetic progression. Let's say a is 1, right? The starting term. And the common difference is 2 because some odd numbers. And let's say we want to do the sum of n numbers. So what is Sn? Sn is n times average of the very first and the very last term. The first term is 1. Okay, I'll just write first term plus last term divided by 2, right? The first term is just 1 itself. First term is 1. And the last term is, or rather the nth term is 1 plus n minus 1 times the common difference, which is 2. Okay, let's see what this adds up to. So this adds up to n into 1 plus 1 plus 2n minus 2 whole divided by 2. So this nicely cancels out. This nicely cancels out, leaving n square. That's how you get sum of odd numbers is n square. You can prove it just by simple arithmetic progression. Navia, you're able to, could have proved this as well, right? All of you could have proved this using sum of terms in arithmetic progression. Suhani, you as well? Veer?
Yeah, I got to the part where it comes to the sum of odd numbers, the squares, and then I could progress
Correct.
further.
Yeah, that's fine. But sum of odd numbers is perfect square. That I'm sure you knew this, right? Veer? Okay.
Yes.
So we are looking for n square greater than 2000. But then how do we, from here, Swani, since you are a little skeptical about your mental math, how do you approach, you think, from here? How can you say, now you heard the answer, but how would you have approached?
Like when you know that it's like
n square is greater than 2000. So how do I know what is approximately square root of 2000?
so you could do 30 squared as 900, which
Yeah.
you know for sure. And then not sure how you'd get to like the specific 44.
Okay. So 2000, right? So for example, even here it's easy. Okay, in fact, I'll give another problem after this, right? Which is guessing perfect squares, right? So you can ignore this last, since we are looking at perfect squares, we can start ignoring pairs of digits from the right end. Let's focus on 20. right? 20 is between which two perfect squares? 4 square and 5 square, correct? Which means 2000 is between 40 square and 50 square. Because we have 2 zeros added for every 10, right?
Yeah.
Because 40 square would be 4 square times 100, which is why I eliminated 2 zeros in the first place. Right? So I know a number between 40 and 50, and you can, it's like 60, and this is exactly almost roughly halfway between these two. So I can start with 45 square as an initial guess, right? And any number ending in 5, uska rule pata hai, all of you? How to square a number ending in 5? So if I have a number, let's say, I'll just take another, because in this case, it might be a little confusing. Suppose I have 65 square. All I have to do is put 25 at the end, and then multiply 6 with the number after 6, which is 42. So 4225 would be 65 square. Yeah, Veer, you know this trick?
Yes.
Ending in
I do.
5 wala square. Navya, you as well? Okay. So yeah, so in this case, 45 square would be, I'll just put a 25, and then 4 multiplied by 5 would be 20. So 2025 is 45 square, very, very close to 2000. And we just have to, we don't even have to experiment. We can clearly see that 40, I don't even need the numerical value for 44 square. That's another 5 seconds wasted if you didn't know automatically the value. Why? It's definitely going to be below 2000 for sure. So 44 days for sure. And then the 45th day is when this will be uttered, when the sum will be this. Okay, all of you good know. Now, one more variant of this question. Now he runs a running sum, not each day sum. So we said that the first day sum is 1. We said the second day sum is 2 square, which is 4. Okay, so first day the sum is 1. This is 4. This is 9. This is 16. All that is fine. But he keeps adding cumulatively. So right. So on the first day he counted 1. Second day his sum was 4, but he added it to 1. So it's 1 plus 4. And now he's adding 9 more. Now he's adding 16 more. So same question, I want to know which will be the day when this cumulative sum will exceed, let me make up some other number. Rather than 2000, I'll make up a little bigger number. Cumulative sum will exceed 5000. Is the question clear?
So I don't understand what cumulative sum is.
So the sum on the first day is 1. The sum on the second day is 4. The cumulative sum till the end of the second day is 1 plus 4.
Oh, okay. So
Cumulative sum at the end of the third day is 1 plus 4 plus 9. In other words, I want you to tell, so this, so on till n square, we all know it's n square, should exceed 5000. Find the smallest n. Yeah, question is clear to everyone? All of you guys know the sum of 1 square plus 2 square ka formula pata hai, all of you? So you understand Hindi, right? If I speak 1 or 2 sentences in between in Hindi, you're okay,
Yeah,
right?
I get a little bit.
Okay. I too am not a native Hindi speaker, but in between like 1 or 2 sentences, it just comes, right?
Yeah.
So do you guys know so just like you guys know the formula for 1 plus 2 plus 3, so on till n is n into n plus 1 by 2. What is 1 square plus 2 square plus 3 square, so on till n square? Uska formula. Anyone? Navya, would you know this? Okay, where is she? I don't know. Okay, Veer, would you know this?
no, I don't know this formula.
No, sir, I don't.
Okay, all right. Okay, so good. Not good. I mean, I'm just, I'll tell you. So it's n into n plus 1 into 2n plus 1 whole upon 6. You should know this, guys. It's very, very fundamental. Okay. And then on that same note, I'll do the cubes as well. This is easy. 1 cube plus 2 cube, so on till n cubed is nothing but, we got n into n plus 1 by 2, right, in the first one. Uska square. So we can just experiment, for example. So let's say 1 cube plus 2 cube plus 3 cube plus 4 cube. So it'll be 1 plus 2 plus 3 plus 4, which is 4 into 5 by 2, right? N into n plus 1 by 2. Uska square, it'll be 100. You can check. 1 plus 8, 9. 9 plus 27 is 36. 36 plus 64 is 100. So these two are very connected. This one ka square is this. Okay. Now this, the beach wala, this is the sum of squares is this guy, which is what you will need for solving this question. Okay. But by hand calculation, how do you arrive at this? So that's where the challenge is. So I've given you the formula, no calculator, find an n when this happens. Navya, your video is off. You're okay to turn it on?
Oh yeah, I didn't notice.
You don't have to give the precise answer. Somewhat close to that range is also fine with me. No? Anyone? How to approach this without calculator? Let me know when you guys want to discuss.
So I tried solving, but then I reached the original answer itself.
Meaning? The
Like
44.
No. I
Ah.
like so I multiplied 5,000 by 6, like I took 6 to the other side.
Yeah.
Then I solved it, but then I got like n plus 1 to n plus 1 again. So
Yeah, correct. But then, all right. Okay, fine. Let me just make space here. I'll just erase this formula. Okay. All right. So what do we want? We want n times. Okay. So we want n times n plus 1 times 2n plus 1 by 6, like you said, to exceed 5,000. So I'll just move the 6 to this side. So I want the product of this to exceed 30,000. Correct? So far, so good. I've not done anything beyond taking the 6 to the other side. Now, n is fine. N plus 1 is also fine because I can approximate. I can guess that the n will be a fairly big number, which means n plus 1, more or less, they're going to be in the same range. Now, how do I deal with this 2n plus 1? I can just do some approximation. I'll just write this is n, not approximation. I'll remove the 2 outside here. So 2 times n times n plus 1 times n plus half is more than 30,000. Correct? Now you'll see why I'm doing this, right? So this, okay, I'll move the 2 to this side. I'll make it 15,000. I divide by 2, getting 15,000. Correct? You're okay with me so far? Now, n plus half, and n plus 1 are all fairly tightly close, right? So I can approximate this to be approximately n plus half whole cube. right? So we are looking for a perfect cube which is close to 15,000. Are you guys okay on this one? So, are you okay? Okay. Now, how do I find 15? How do I find the cube root of 15,000? So, same idea. I'll start eliminating 3 digits now because I have to find the cube root now, right? So in other words, now I'll just focus on 15, which is the cube root. That 15 is sandwiched in between. It's sandwiched in between 8, which is 2 cube, and 27, which is 3 cube, right? And this 15 is somewhere in between, right? I don't know what it is, but it's somewhere 2 point something, let's say 2 point, I'm just making up some random number, right? It's closer to 2, but then I don't know how close, very roughly, it's to a 2.4, let's say, or 2.3, doesn't matter, right? Which means this number, if 24 is, if I multiply by 10, because there are 3 digits here, right? So my best guess would be 24. I'll start with 24, and then I can operate in that band and then quickly figure out. I'll try n equal to 24, and then I can quickly, this calculation I can do. So if n is 24, then I'm looking at 24 into 24.5 times 25, right? Which I can easily approximate it to be, right? So 25, let's say it's, okay, fine. In fact, I'll approximate the middle number, right? If I approximate n plus half to be around 24. I mean, n has to be an integer in this case, I know, but I'm just saying this is easier if I calculate this way, right? So the middle is 24. So what is 24 cube? So what is 24 cube? That can be, I haven't done much more than this. 24 cube can be manually done fairly easily. 576 times 24 can be manually done. It doesn't take too much effort, right? So let's do it. 24, 2 carries, 28, 30. So 2304. Just if I'm doing some silly mistake, call it out, please. 12, 1 carrying, 15, 1 carrying, 11. Am I right? Okay, so when we add, what do we get? We get 4, 2, 8, 3, 1. So I'm fairly close, right? So 24 cubed is almost there. I'm sure with 25 cubed, it'll exceed. Or in fact, 25 cubed, you know, it's 15625 if you know perfect cubes. So I know, at least I'll know, I don't have to search too hard. It'll be somewhere in the range of 24, 25 K-pass. Doesn't make sense. And that's exactly what I want. I want you guys to learn approximation skills, which is important. Yeah, Navya, you're good with this approximation?
Yes, I got it.
Okay, cool. Veer, you're okay as well?
How do you know that to take 2.4 and not any other?
Yeah, so that we don't know because 15 is, so generally, how do cubes go? So so if I have to plot x cubed goes very steeply, right?
Yeah, it's like
Right? It's very steep, like, okay. Right, very steep like this, right? So this is 1, this is 2, and some scale, right? So this is 3. So this is 8. Again, I don't expect you to do in the exam pressure. So this is 27, right? So so I'm talking about 15, which is closer to 8, right? Very roughly, I'm just saying, right? It's closer to 8 than to 27. Therefore, I went closer than 2.5, closer to 2 than to 3, which is why I started with 2.4.
Wouldn't you take 23 then?
23, yeah, should have been but even with 24, it doesn't work here, right? Because it's steep, which is why I went with 24, because you have to cross more to reach, or other words, to reach halfway point. So forget, so 8 and 27, what is the halfway point between 8 and 27? It's 35, correct? 35 divided by 2, which is 17. So to reach 17, I'll have to go closer to 3 and not. Are you with me?
Yes.
Okay, so oh gosh, no, this is all interesting. I love this, but I just, mental math is difficult to describe. So this is 8 is here. So 2 cubed is 8. 27 is thrice that. 27 is more than thrice that. It's somewhere here. So, and 1 cubed is 1, right? So it's 8 times, and 0 cubed is 0. So the graph is actually very steep, like this. Okay, again, it's not for exam, right? So all of this experimentation is during, we have ample time and we think about all this. And then in the exam situation, things will click a lot faster for you guys. So this is 8 and this is 27, right? So if I'm looking at a number which is halfway between 8 and 27, I'll have to travel closer to 3 than 2 because it's very, very steep. It's probably, if you pull out your calculator, just check what is the cube root of 17.5. I'm sure it'll be something like 2.8 or something, much, much closer to 3, even though 17.5 is halfway between 27 and 8. Can you pull out your calculator and see what is 17.5 ka cube root? My guess is approximately 2.8.
It's 2.59.
Oh, is it? Okay, it is not that close as I thought. Okay, so 2 point, but still it's closer to 3, 2.6 rather than exactly 2.5, which is, I'm looking at 17.5, which is exactly halfway between 8 and 27. But conceptually, you understand, guys? Make sense? Veer, you with me as well?
Yes.
Okay, Sanvi. White girl today, Sanvi. All good? Okay, good. Thank you. Okay, nice. Question 5. Tokens. Veer, you're able to do this one.
Yes.
Okay. What did
Okay,
first? Let's call out your answer. Let's see if this is consistent with others. What did you get?
my answer is E103.
Okay, Suhani, did you get the same? Sunny, are you on? Your video is off. Navya, what did you get?
Yeah, even I got 103.
103. Okay. Veer, can you explain like how you do this?
Yes. Okay. So what I did was I said that he starts with 75 red and 75 blue
Yeah.
at the first stall. At the end of the first booth, he exchanges his as many reds as possible, so he gets 1 red and 37 silvers, and he continues with the same number of blues. Next, he goes to a blue stall, and there he exchanges all, and then he exchanges, and then that process keeps continuing until eventually he's left with 1 red and 2 blues and 103 silvers.
Understood. And why did he start with 2 reds initially? Why did he not go to the blue booth first?
It's an assumption that I made.
Okay.
That he starts with red.
Okay. So how do you know that would work out to be? If you start with blue, then would you get the same answer or would you get a different answer?
It would be the same, right? Why would it change?
Yeah. And why
They're
would it be same?
independent events. They're independent events because the number of blues really doesn't make an impact on the number of reds since they're interacting separately.
No, but you start with blues, then you keep exhausting blues and start accumulating a lot of reds.
Exactly.
Yeah, but I'm still not clear on why it would not matter. That explanation I'm not clear. Navya, do you think it will matter? If not, why won't it matter? Suhani, are you back? Can you turn on the video?
I mean, it does. I didn't really think about it when you said, like, when I was solving, but at the end it says that how many silver tokens will it have. So I think that sort of implies that it's all the same, and there's no,
Yeah.
like, isn't it maximum value or minimum value? So that means they're all the same, so it won't matter.
Yeah. Back to what Veer was also explaining. Yeah. So it won't matter because ultimately what will you do? As long as you have 3 or more blue tokens, you will want to keep repeating the process. As long as you have 2 or more red tokens, you want to repeat the process. So ultimately, doesn't matter. As long as you have some number of tokens that can be exchanged at a booth, I'll keep doing that because I keep accumulating silvers, like, right? So it does not really matter. Maybe that's what you're also conveying anyway, Veer. But yes, yeah, makes sense. Okay, and the answer was 103, is it? It's just as long as you don't do silly mistake, I think it should be fine. You just have to keep counting. Suhani, are you back? Video's off. I cannot tell. Okay, all right. I'll move on. That was question 15. So just for those people who are watching on the video, right? So this is the starting process. He says he wants to exchange the reds. So here, so this is reds and this is blues. Okay, so this is 75, 75. Okay, maybe I'll use a neutral color so that it should not be biased. Red and blue. So 75, 75. You exchange all the reds, right? So which means there are 74 reds, right? You subtract 74, and then you have accumulated 37 blues and 37 silvers. Okay. Now you go and exchange. There are 112 of these, and then you exchange. Keep seeing how many multiples of 112. I think 37 times 3 is 111. So you'll start with exchanging blues for reds, and therefore you'll be left with 1 blue, and then 1 plus 37 reds, and then you have 37 silvers. Again, you have 38 reds. Go and exchange the 38 reds. So you can exhaust them to 0 because 38 is an even number, and you'll accumulate 19 more, I think, of these blues, and so on. And then, as maybe I'm doing a silly mistake, but yes, essentially you have to keep adding up the number of silvers until you're left with fewer than 2 reds and fewer than 3 blues, so that no exchange can happen after that. Okay, cool. Just thinking any other variant of this question is possible. Okay, fine. Okay, nothing comes to mind offhand. Fine. Question 5, that was. Question 6. Suhani, did you do question? Oh, by the way, question 5, Suhani, you're okay as well? You got 103 like these guys?
Yeah. Oh wait, no, I didn't fully complete it, but I understood when
You
you
understood how to
tried.
do it, right? Okay, cool. Question 6, were you able to do it, Suhani?
Once again, like I tried, but I wasn't like too sure. So I got like that the thousands digit needs to be 1 or 2 because like it can't be greater than
Yeah.
2013. And then I got that I think the lost digit has to be less than or equal to 9.
Yeah.
But yeah, I wasn't really sure like how to.
The first digit is 1 or 2, but literally if it's 2, there are very few numbers. There are only 13 numbers. You can even hand count and just check. In fact, if the first number is 2, right? So essentially you want, let's say this is A and this is B. We want this number to be 2 plus A plus B, correct? Right? So 2 plus A plus B. So, which is, right? So can this number be, so we can literally count between 2000 to 2013, what would A and B have to be? And in fact, A has to be 0 or 1, right? A cannot even exceed 1, right? So there's very few choices. So it can be 2000, and it can be 20 what? 1, 1, and that's it, right? Is there anything else possible? Just these two, right? The 2000 series. Oh, sorry. 2002.
Wait.
I mean 2002.
Yeah, I got my
2002, and this will be 2013. Oh, but 2013 we cannot even count. So literally only one number in the 2000 series. Not a lot at all. We can literally hand count, and we hand counted it to be only one number. So practically we have reduced our question to the first digit has to be 1. And let's say this number is A, this number is B, this number is A plus B plus 1. Okay, all right. So Navya, what answer did you get on this one?
I got D.
D46. Okay, and Veer, what about you? I cannot hear you. You're on mute.
I was sorry, I was muted. Question 6, I wasn't able to do.
Okay, but so far you're able to follow Veer?
Yes,
okay,
I am.
So this is 1, A, B, and A plus B plus 1. Okay, and Swani, you're also with me? Okay, right. So now, A plus B plus 1. So what are the constraints on A plus B plus 1? So first of all, A and B have to be both greater than or equal to 0. That's obvious, right? I don't even have to write it. They are all digits. But A plus B plus 1 has to be a digit, which means A plus B plus 1 has to be less than or equal to 9. Correct? It has to be a digit, which means A plus B has to be less than or equal to 8. So we need two numbers, A and B, whose sum is less than or equal to 8. So let's use a basic number line. not number line, x-axis, y-axis. So if I plot A on this axis and B on this axis, so let me see when will A plus B be equal to, when will it be equal to 8? It'll be the line A plus B equal to 8. So for example, A plus B equal to 8 is what? Your x plus y equal to 8 types, which means y is 8 minus x, right? I wrote it as x plus y so that you guys are more used to y and x, right? So that'll be like what? Like a line like this with a slope, sorry. So a line like this with a negative slope, right? Yeah. So what are some of the points? So this extreme point would be 0, 8. And this extreme point would be 8, 0. And there'll be points here like 1, 7, whatever, 5, 3, all of these points where it'll just reach, this is A and this is B. So all of these integer points, which are within this triangle, are all counted, correct? So Ani, you're with me so far? Yeah.
Yes, sir,
And
yeah.
yeah. And then start. So how many are there? Suppose we count here. So there are starting from 0, 0. First of all, extreme cases, we have to be, can A and B both be 0? A and B, if both are 0, then we get the number 1, 0, 0, 1. Yeah. Is 1001 included? Yeah. 1001 is still valid, right? Because it has to be greater than 1000. Yeah. So 1001 will be the first one. So even 0, 0 is included. So starting from, so in this, if I start counting in columns, right? In this, there are like this, there are many. How many are there? Starting from 0 all the way till 8. So there are 9 numbers here in this first vertical. In the second vertical, there'll be 8. In the third vertical, there'll be 7, all the way till 1 in this case, right? So we have 9 plus 8 plus 7 all the way till 1, which is 45 numbers. And then, of course, not to forget this one single number that we have here, which is 46. Does it make sense? Navya, is this how you arrived at 46 as well?
Yeah, basically.
Basically, yes. Okay, cool. Any other question? Let's see in this one. Okay, all right. I'll just make where instead of sum, I'll make it product. So 2012 has the product that it's no, actually even 2010. Or actually, I'll just say 2136 is an example, right? So 2136 has the product that its units digit is the product of its other digits. So 2 into 1 into 3 equal to 6. That's just one example, right? Can you find how many integers with the same restriction? Let's say between 1000 and 2013 with this property. So 2 into 1 into 3 equal to 6 in this example. So essentially, you guys get the idea, right? Instead of sum, suppose it's product. Can we approach it and do it?
So can you just repeat the question? Like, I feel like I missed out on some detail.
Uh, okay. I've given an example number 2136, which is obviously not within this bound. 2136 is a number where the product of the first 3 digits is the 4th digit, right? How many digits, how many numbers in this band have that same property? Yeah, go ahead.
I got 23.
23. Okay, all right. Sorry, say that again, Navya.
1 second, I just didn't count 0. I just got 42. I just resolved.
42. Okay, all right, let's discuss. Same idea. So, Veer and Suhani, anywhere close? Almost 46 as well. You as well, or where are you?
I didn't get an answer yet, but
Okay, all right. Let's start with the one, starting with the ones place, because with 2 starting place, it's very easy. We can finish it off quickly, right? So again, same thing, A, B, and the product is AB, right? This is the digit. So the AB can be, yes, 0 is an important number, right? We cannot miss. So AB can be 0. In fact, I'll write out the product AB. AB can be 0 or 1 or 2 or 3 and so on, right? In fact, let's do everything just manually, right? It's much easier that way, right? Now, I need a combination of A and B where the product is 0. So literally A can be any number from 0, 1, 2, 3, so on till 9. And B can be any number from 0 to 9. There are 10 into 10, 100 possibilities. Am I right, or am I off big time? Yeah. Right. So for example, one example number would be
Why is it 10 into 10?
because A can be any one of the, sorry. I'm sorry. You're absolutely right. It's 10 plus 10, right? If A is 0, then B can, okay, both cannot be simultaneously 0 because 1000 cannot be included. Correct. So both cannot be simultaneously 0 because 1000, then the answer will be 1000, which is not valid, which is not within our range, even though it's a valid number, right? So if A is 0, then B can be anything 1, 2, 1 till 9. And likewise, if B is 0, A can be anything from 1, 2, so on till 9. So which is 9 plus 9, is it 18? 18 numbers is what you counted as well? Okay, good. Maybe I made a mistake. Not maybe, I did make a mistake. So 18, sorry?
I got 19 because I took 9 plus 9 and then I did plus 1 because 0, 0 also has to be counted.
But 0, 0 should not be counted because if it's 0, 0, the answer will be 1000 and 1000 is not counted based on this greater than 1000, right?
Yeah.
Which is why 1000 should not be counted. But yeah, that's fine. Silly, because you have to read the question with greater than equal to. People can make up question whatever they want, but you have to be careful of the extreme edges. Okay, now 1 and onwards is fairly easy, right? The only way to reach 1 is just 1 into 1. Only way to reach 2 is 1, 2 or 2, 1. How many ways can I write out 2, right? In fact, for every prime number, it will be only 2 ways. 1, 5 or 5, 1. 1, 3 or 3, 1. 1, 7 or 7, 1. These are the prime numbers. Now, 4 ke liye, you cannot just count the number of factors. You can literally count the number of factors also. Okay, so 1, 4, 2, 2, and 4, 1. So 3 ways. For 6, it's 1 and 6 and 2 and 3, and that can be swapped as well, right? So there are 4 ways. For 8, we have 1, 8, 4, and swapped as well. So 4 ways there. For 9, we have 1, 9, 3, 3, and 1, 9 can be swapped as 9, 1 as well. Therefore, the 3 ways. So as long as we add all of them carefully, we should be fine. 19, let's see. I get 41 here. Just let me know if I'm counting it wrong. 41 here. And then of course, in the 2000 series, there'll be, so if this is 2, okay. And then if you have the first 2000 series, 20, blah, 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 this obviously has to be 0, right? So this can be 2000, it can be 2010. Both of these numbers are included. And then, and that's it, is it? Or it can go to, yeah, that's it, right? Because if I have to have a non-zero number, this has to be 1, right? And then that will cause this number to exceed 2000. So there are 2 numbers here. Yeah. So 41 plus 2, 43. Is that what you said, Navya? 43, or what did you say? 42. What did you say?
42, but then if you exclude 1000, then I get 41.
Huh. I'm getting 41 in the 1000 series and 2 more in the 2000 series.
Wait, how are you getting 2000? Because 0, oh,
2000 and 2010.
I didn't count the 2000 series.
Yeah. So we are consistent now, right? 41 plus 2, 43. Same answer.
Yeah.
Okay. Makes sense, Suhani, Veer, everyone. Okay. Sanvi, thumbs up. Okay, good. Okay, cool. Do you have time for one more, or let's see? Okay, maybe we'll do one of the easier questions.
Sir, I need to go. I have another.
Okay, that's fine. Actually, we are up at the end of the time as well, right? So let's fine. Let's continue. I don't want to rush. All of these questions, I like to make variants of this question just to make sure you actually understood, right? So, and as you do problems also, you yourself think if the question is framed this way, how do I approach, right? Get into the practice. Chalo, bye. See you.
Bye, so thank you.
Thank you.